All right, I think then let's get started. So first of all, welcome to this talk about Papyrus. Let me introduce you to my colleague Camille. He is a software architect with Eclipse source in the office that we have in Paris. Myself, I'm Philip. I'm the software architect working in Vienna, Austria, also for Eclipse source. And in today's talk, we are talking about Papyrus. In particular, we would like to have like 3 parts of this entire talk. So in the first part, just in case you don't know Papyrus, we briefly introduce it and talk about how we in our projects mostly use Papyrus. In the second talk, we would like to give you an update on what has happened in the last few years. And in the last and third talk, I would like to propose a couple of future directions where we would like to go with Papyrus. So we would like to cover the evolution of Papyrus and then also get your feedback on what you think, whether our directions do make sense for your use cases and your projects. Good, so let's get started. Just so that I have a feeling, who of you already knows Papyrus? Maybe you can show, okay. It's like, I would say 20 to 30%, maybe more. So I will just give a brief introduction. So Papyrus is an open source UML modeling platform. And with that, it allows you to, within the Eclipse workbench, to create UML models, also create SysML models, FUML, as well as ELF, that's the textual action language for foundational UML, and create those models, manage them, and produce some sort of artifacts out of them. It's, as I said, open source, and it's part of the Eclipse Foundation. With that, of course, as for most of the Eclipse Foundation projects, it has a very active open source community that maintains and evolves this project. And one of the aspects about Papyrus that is very important for us actually is that it enables you to build domain-specific tools based on UML. So you're not just an off-the-shelf UML editor, but you can more streamline it for your needs. And the reason why this is very important for us is that from our experience from the recent years when we built with our partners modeling tools and introduced them in their development workflows and organizations, we sort of observed that model-based engineering in general seems to be most successful when you build a modeling environment that is as domain-specific as possible. And what we mainly mean with domain-specific is that the whole modeling environment is highly customized, taking into account the requirements and the specific needs of the domain in which you want to introduce this tool. Of course, you need to also take into account the users, their backgrounds, their methodologies, as well as their tool chains, to make sure that the modeling experience isn't something isn't an alienating step within the workflow, but it's really just part of the typical day. And talking about domain-specific modeling environments, usually they consist of a couple of pieces. So first of all, we have here a domain expert, for instance, who works with this domain-specific modeling environment. And of course, domain-specific modeling environment is way more than just a diagram editor. It's just one thing that the domain expert uses to interact with the actual domain-specific modeling language that's behind it. And then, of course, we always would like to produce a value for the domain engineer or domain expert out of those models. So we typically have a couple of components in the back that, for instance, generate code, generate documentation, do some early validation or verification based on simulation components, and so on. And those components will then produce a value to the domain expert in terms of answering questions about performance or completeness or whatever the domain expert is interested in. Since it's domain specific, this editor part can have various shapes and forms. So talking about diagrams, for instance, when you have a domain specific modeling language with diagrams, then obviously you also should have shapes that reflect sort of a typical graphical concept in this domain. So for instance, I don't know, when you are modeling mobile network, the architecture of mobile networks, and you have something like service cloud components, then of course it shouldn't be just a rectangle, but it can be a cloud or whatever figure you would like. So typically this is something that you find in the PowerPoint presentations of your domain experts when they try to convey or to explain some sort of aspect or concept in their domain. Then they draw figures anyway, right? and from this you can directly then learn what actually are the figures and shapes that those domain experts are using for communicating, and they should also be, of course, then reflected in the diagram editors. Of course, maybe some aspects can be very well handled with diagram editors, but maybe there are also aspects which are better served when you use text-based editors for certain aspects, or table-based editors, or even form-based editors. Domain-specific modeling is not just diagramming, but really using the representation that makes most of the sense to efficiently support the domain expert. So I've now talked a lot about domain-specific modeling, of course, and how beneficial it is. Of course, standardized modeling languages like UML and SysML have a lot of advantages as well. The obvious ones is that since it's a standardized language, it's well known and very familiar to many people, and you can reuse those concepts that have been established in this standardized modeling languages also for your modeling purposes. So that's great. Also, since it's standardized, there are already a couple of tools existing. One of them is, of course, Papyrus. So you can reuse those existing tools and you don't have to build everything from scratch. Another advantage, and that's actually a huge advantage that is maybe not so clear in when you first think about it, when you build something based on UML, then those UML models will always be interoperable with other UML models. So, for instance, when two groups of your organization both build certain aspects in terms of models based on UML, you can connect those models under the hood so that they are, for instance, you have trace links among those pieces, and that's actually something that is very, very useful, because in the end, modeling is about creating a large picture and an integrated view on your system at hand that is interconnected. So that's really a lot of advantages for standardized modeling languages, especially UML and SysML. But before I told you how great and successful domain-specific modeling is, so now you might want to ask whether that's actually a contradiction. And in our opinion, it is actually not a contradiction at all, because when you look at it very closely, actually what the main difference between using UML for your project or domain-specific modeling languages is when you combine the benefits, it's actually not about the language, but whether the tool is off the shelf or whether the tool is customized for a specific domain. And if you have a UML platform that allows you to be customized for your domain and that supports domain-specific diagrams, for instance, then you can still use UML and provide a domain-specific user experience. And that's actually how we use Papyrus in most of the projects. And Papyrus, I will show a demo of that later, supports all these customizations to make it domain specific. Another thing that is really great about Papyrus is that it's based on EMF and Eclipse RCP, because that actually allows you to integrate Papyrus with all the other great technologies that are out there in the modeling domain in Eclipse. So that means you can integrate it with Xtext to have textual languages, for instance, as well as form-based and even domain-specific graphical languages that have been built from scratch with Sirius. So you can, since both is EMF, you can just combine them as you wish. So how does that work using Papyrus as a platform? How do you add the domain specificness to your UML models? Basically, out of the box, Papyrus supports all UML concepts and gives you generic editors for that. There is within UML a specific concept that is called UML profiles, which allows you to extend the UML language itself and add domain-specific things. So when you think of your domain-specific modeling language that you would like to build, and then you overlay it with UML, you will most likely see that there is a part that is not covered in UML at all. Then there is a part that is maybe overlapping, and then there is another part in UML that you probably don't plan to use. So when you put that now in the terms of a profile, how a profile helps you to implement that scenario is you think of your domain-specific modeling language as a number of concepts. Those that can be reused from UML, you map them to the existing ones in UML, and those that cannot be directly reflected in UML, you will add in your specific profile that then is put on top of UML. With that, you can extend sort of the modeling language itself. Of course, that doesn't give you already a finished tool. Just provides you the modeling constructs, but as I mentioned before, Papyrus provides many customization options and sort of UML platform capabilities that you can then also put on top of this UML platform DSML customizations, with which you then can, for instance, customize the graphical syntax as well as the tooling for editing the models, and also make it domain specific, so that users actually have the user experience of directly interacting with a domain-specific modeling language without even knowing that under the hood UML is actually used, which is great. And last but not least, as I mentioned before, since we are building on top of Eclipse as a rich client platform, it's easy to implement certain workflows and methodologies to guide the user through the methodology that you are using by, for instance, introducing dedicated wizards, menu items to generate from one step the stubs for the next modeling step, and so on. And you have a very powerful API based on the Eclipse modeling framework to then write those components, if you remember before, that produce value out of your models. So for instance, code generators, analysis tools, and so on and so forth. So that's really something very great, and that's actually how we mostly use Papyrus. So we take it as a base and then make it domain specific to meet the requirements of a specific domain. Just so that you have a feeling how this actually looks like. Basically, there is a small example that I would like to show. So think of you would like to create a workflow modeling language which consists of manual tasks and automatic tasks, for instance. Between those tasks or among those tasks, you can have sort of a flow and things like parallelization or decisions. And you want to record for each of those tasks, for instance, how long they are going to take, who is responsible for them, and for all the decisions you want to record probabilities, for instance. So as you can see already, this might be looking very close to an activity diagram, but of course an activity diagram doesn't address all the requirements that you have, like it doesn't know about manual tasks, about probabilities, responsibilities, or something like that, and that's exactly what we would add. And I will just show you very quickly in the Papyrus workbench how you can create that. So let me switch to the demo. Yeah. So basically, what I have here is a plain activity diagram. So you see that I created some actions here. We have flows between those actions. We have decision nodes and merge nodes. And this is just a plain activity diagram as you will find it in any UML editor. So what I would like to do now is just to add domain-specific concepts. And I can do that by creating a so-called profile. So I just create a new Papyrus project. I select that I would like to create a profile for my domain. I will just call it now. Oh, sorry, it's a French keyword and I'm not too used to that. I will create a new project and initialize it with a profile diagram. So as soon as I hit next, I'll get an empty canvas. Currently, it doesn't contain any domain-specific concepts yet. So first of all, for instance, I would like to annotate the probabilities of those flows, and I can do that as soon as I click on them. Papyrus shows me what is the actual type of this flow. It's control flow. So now I can go into the profile and import the control flow class by import meta class is the name. Then a dialog will appear where I can look up control flow. I will edit, hit OK. And now I can create so-called stereotypes in order to extend this type to add domain-specific concepts to it. So I create a new stereotype and I will call this weighted flow. And I specify that weighted flows can be applied to any control flows. So with that already I can now mark specific control flows as being to be weighted flows. But of course I want to also store additional information about it, like the probability. So I will just add a property, just like you would do in class diagrams, that is then called I will just call it prop because I'm not sure how I can type on this keyboard. And I will, for instance, specify the type to be something from the primitive types, and in particular I would like to use integer, for instance. Now I can save that, hit yes, then Papyrus has a versioning support so that you can track which version of the profile is actually being already defined. And now I can go back to this model and apply this profile. Here, sorry. No. Here and select the profile I've just created. And that's this one. Hit OK. Okay, done. And as soon as I have done this, I can select any control flow that I have in my model and actually apply the stereotype that I've just created, this weighted flow, hit OK, and now I can already specify an integer for this value. And as soon as I enter something here, which I can't do because I can't use this keyboard anyway, then it will be stored in part of the model. So that's all fine, and in order to avoid you having to watch me creating the entire diagram, I will just, I've already prepared it like sort of in a cooking show. I have created exactly the same model as before and completed the profile that contains all the concepts that I would like to add, like automatic tasks, manual tasks, weighted flows with probabilities and so on, and I applied it to this model. So this now already contains all the information that I actually would like to capture. Now, of course, I would like to do more. I would like to make it domain specific also in terms of the diagram style and the looks. And in order to do that, Papyrus supports sort of a CSS language, CSS-based language, in order to define the shapes and style of the diagram. And as soon as I apply this to this diagram, you see suddenly you can do turn it into something more domain specific. You can even go way beyond that by replacing entire shapes with SVG shapes and so on and so forth. So that's pretty nice, and this language is actually really simple and easy to use. I'm not sure if you can read it, but basically you have the selector part where you specify, okay, I want to now define the properties of all elements to which the automatic task stereotype is applied. Then I specify that it should be gray and it should have some symbol based on SVG, for instance. And that's exactly what we see here. This automatic task is gray and has these symbols. So that's really cool. Of course, you want to go way beyond that, because now still you see that here is, we have already a kind of domain-specific diagram which captures all your domain-specific information, but still the palette and all the tooling is still the basic UML palette, and exactly that's what's make Papyrus a platform. It allows you now to also customize the palette, the property views, the right-click menus and all that stuff, so that you can only show the part that is relevant to your domain. And we have prepared a tool for that, which is exactly the same what we just saw, but we also more or less implemented all those extension points. So you see here now in the palette, only automatic task and manual task is shown and not all the other rest. And the property views only shows, for instance, that for a send form, you have only a name, a duration, and the component that is responsible for it. So that's then more or less already very, very close to a completely domain-specific diagram editor. Right. So I've already talked about the custom tooling. I don't want to go too much into detail, but of course, Eclipse also provides you way more things that you can actually do. So for instance, you can attach a code generator to it. You can do validation tasks and print results and so on. So that's all really easy to do, because Eclipse is like a platform for building tools, so you can make use of that. Actually, so that brings me to the second part, where I would like to talk a little bit about what has been happening in the last 1 or 2 years around Papyrus. And one thing that I would like to mention is Papyrus UML Lite, which is actually an example of what I've just shown. It's basically a customization of Papyrus for a specific use case. And in this particular case, the use case is sort of to have an optimization for the most common UML features. So as you probably might know, UML is a huge language. It has many, many different language concepts. And probably at least in my life, I have never met a person who actually uses all of them. It's really, you have to decide what you use. and this is kind of an entry barrier. So what we built, and that has been funded by the Papyrus Industry Consortium, what we've built is a streamlined tool that is way simplified in comparison to the normal Papyrus, and that only provides the most common features. And we identified the most common features by looking at the OMG certification levels. When you are actually being certified to be an expert in UML, there are these levels, and based on those levels, we built Papyrus UML Lite. And I will just show you that a little bit. So aside from reducing it, we also streamlined it in terms of that it has a very nice appearance, looks more modern with this bluish background thing. I'm not sure you can get the beauty of it through the beamer, but it looks quite nice. I can say that because I didn't do the styling. And as you can see, for instance, here there is not a lot in the palette, as well as when you, for instance, right-click here and create new childs, there is only a few concepts that you can add. That's the most important ones. When we compare that, for instance, with the generic editor that we had here, and we go to new child, see that you even can scroll down here for a while, and that's basically all what we don't want to include. So also in some way it guides the user of what can you actually create now in a package by creating a new diagram. There is only this specified number of diagram types, and then for each diagram type, which elements can you actually add. And of course, also in the property view, only the most important things are listed, and not the very complex features. The good thing, and that's also the reason why I am highlighting UML Lite, is it's open source. You can, first of all, of course, use it, but you can also use it as a blueprint for creating your own domain-specific modeling tool based on Papyrus. We even documented all the customizations that we applied to Papyrus, how they are working, and how you can do them. So you can just, here is the link, go to GitHub, download it, and try it out yourself. Another thing that I would like to highlight is that has not been implemented by us, but by CEA, is that there is now support for SysML 1.6. So that's on the one hand side, of course, the implementation of the profile, but including all the diagram and element types so that you can actually create them using the tool. And there is also an implementation tool from SysML 1.4 to 1.6, and that's something that also a lot of users of Papyrus appreciate a lot. Oh, sorry. Now what to do is finally, what has been improved a lot in the last couple of years is a project called Papyrus Compare. I'm not sure if you have heard of it. No. So Papyrus Compare allows you to difference and to merge Papyrus models. So when you have multiple versions of models, you can identify all the difference among them. And the cool thing is that it's even integrated with Git, with eGit, the Git integration in Eclipse, so that you can actually use a Git to version your models, do merges, and so on. But of course, based on the model level and not based on the serialized text level, what Git would otherwise do. So that means when we, for instance, create a new element, and the other one would also create a new element, in the serialized version in the file, it might be on the same position, but both changes actually are not conflicting. So Git would still raise a conflict if it only looks at the text files because it's the same position. But from a logical point of view, we know we can still merge them by adding just both elements, right? And that's exactly what Papyrus adds to that. Papyrus Compare adds to that. And there has been a lot of enhancements last year, especially in the area of performance. So here you see the time needed for merging two versions of a model with 250 diagrams and 230,000 diagram elements. It took more than 3 minutes with the last version, and with the new version it only takes 40 seconds now, which is still a little bit of time, but considering that you have like 250,000 elements, it's already in quite a good shape. I just want to show you very quickly how that looks like. So in this model, actually, just going to the class diagram, this project is currently managed in a Git repository, as you can see here. So we have a repository called Git, and we are on the branch master. And as soon as I change something here now, so let's change the size and rename this element to whatever, hit save. then you see that automatically Git recognizes there is now a change in relation to the latest commit. And you can then right-click and say compare with this head revision, so the latest committed version. Then it shows you all the modified files. And as soon as you open one of those files, you immediately see that we are actually doing a model comparison and not a text comparison, because it tells you exactly that there are two changes: the size change of this element that I just did, and of course the name change of this one element. Sure. It's a so-called notation format. It's very, very close to DI, UML DI, but it's not sure if it's 100% compatible. It's not there, but it's the sort of the closest implementation that currently is available to this. So. Yeah. It's the same with XMI, unfortunately, even though that's standardized, it's still very, very like not working out of the box when you, for instance, export diagrams from rational rows into Papyrus or vice versa. It will always require some fiddling to make it work, and the diagram part is even more difficult. Right, and of course, just that I show you that, you can then here undo and redo changes. So you see here that this changes now the size. And so that's pretty nice. Good, that brings me to the future, sort of what we propose to evolve Papyrus. And what I would like to mention here is that there is actually quite a lot of things that we that are great in Papyrus and that we would like to maintain. So there is so many functionalities in Papyrus, from the support for profile definitions, the language types, model management, all the customizability that I've shown. And that's something that really is something that we would like to keep. In order to evolve it and make more future, meet more future requirements, there is only just two things that might be problematic, and that's the UI technology that is being used and the rendering technology. The reason why I say it's problematic, it's not directly an issue, but we observe that more and more these technologies are sort of aging and in the maintenance mode, and they have certain limitations when it comes to supporting animations, for instance, or very, very flexible styling. So here, for instance, HTML5 or JavaFX is more advanced. But at the same time, we just don't want to throw away everything in Papyrus and re-implement it, but we want to actually reuse or keep a lot of this functionality, but only want to evolve these two parts. So the challenge that we had is how can we do that? And Camille will continue to go into detail. I'm just saying so much that the idea that is that we evolve this UI part and build a layer that can then be extended and used with new technologies like JavaFX as well as HTML5.
Thank you. So the last part will be a little bit quick now because I just have a few minutes to present it. So what is Papyrus GFX? Basically, it's Papyrus implemented on JF5 because the current version of Papyrus is based on JF3. So the goal is to modernize the diagram components and the UI part of Papyrus. Not everything around it, just the diagram part. We also want to provide a more modular architecture to improve extension and customization because that's a big thing in Papyrus. You want to customize it, as Philippe showed that. And we want to preserve compatibility because there are some tools today that are based on Papyrus. And as Philippe just said, we don't want to throw that away and rewrite everything. So we want an incremental migration. So how do we achieve that? First, we remove the JF3 part, which is based on Draw2D. And we re-implement it based on JF5 and JavaFX, which is a more modern UI technology. And as a result, we want to have the current Papyrus diagrams that are implemented on JF5 that are compatible with the existing IDE. So that's a Papyrus editor, Papyrus models, and yeah. So I will skip that slide because I have to be quick and jump directly to the demo. So this is an example of Papyrus. currently implemented with Papyrus on Jeff3, so that's the current version, and it's UML Lite, so it's a customized version of Papyrus. And what we provide now is a new editor based on Jeff5, which can open the same kind of diagram with the same kind of customizations, and just render it with JavaFX and Jeff5 instead. So it looks very similar. There are a few small differences. But we are able to reuse the palette, we are able to reuse shapes, customizations, colors, and so on. And most importantly, we are able to reuse the edition part. So we didn't rewrite all the code required to create elements, for example, or to edit elements. We can still use Papyrus properties view to edit the elements. And yeah, so we can open most of the Papyrus diagrams with this new technology. And it's really the same model that we manipulate, so so if you edit in the old version or in the new version, you see the same thing at the same time. So the integration effort that you have to do, you cannot just take any existing Papyrus-based tool and migrate to JFX like that. There are some custom figures and labels that need to be rewritten because we changed the UL technology. So if you only use standard shapes, then probably you will get it from the base library, but if you had custom figures, you need to rewrite them. Same thing for custom user interactions. So the library provides the basic interactions like moving elements, resizing, creating, and so on. But if you have some more complex interactions, you might need to re-implement them. So it really depends on how much you customized your current diagram, if you have one. The benefit is that you get a more modern UI toolkit, which is JavaFX. So it's really similar to SVG in the way it works, but it also includes some controls like SWT does. So you can do both geometric drawing and control edition. The JFX component is mostly compatible with Papyrus, not 100%, but it's compatible with Papyrus models, including the customizations. We reused GMF runtime, but not GMF diagram UI. So we still reuse most of the services that are currently used in Papyrus and on which Papyrus is based. And I will again skip the last parts. Where can we go from there? We can connect that through GLSP to a web-based client. And I will show that. Now. So this is SIA, Eclipse SIA, which is a web-based IDE. And on the Papyrus side, I started a server which can send models to this client. So I have the same workspace and I can open this diagram, and now I have it on the web. Same thing, we preserve the customization, it's the same model. And we preserve the edition capabilities, creation, edition, move, resize, and so on. If you want to know more about GLSP, there will be another talk about that later in the week. That's Wednesday at 3:10. So the GLSP protocol, what does it enable? It provides a framework for implemented browser-based clients. And through the JFX connectors that we have for GLSP, we can reuse the existing Papyrus diagrams. So essentially, any diagram that is currently supported by Papyrus GFX can be opened with GLSP GFX. Most of the structure and edition is preserved, but the styling needs to be customized on the client side for now. So that's something we need to still support. And I have to stop here. Thank you very much.
Yeah, thanks a lot. I think we are done more or less anyway, and we are happy to take any questions.